Good morning, students. How are you? We have learned about arithmetic progression. Today, we are going to learn about geometric progression. If you observe, you'll find this to be a series, but when you try to find the difference, you will see that the difference varies. So, if the common difference is not the same, we cannot classify this as arithmetic progression. That is the same thing which we are going to learn today. Observe this. This as well is a similar series where the difference varies 1, 2, 4. So it cannot be classified as arithmetic progression. But if you look closely, you will see that the multiplying factor for these are same. Or shall I say, if we divide any number, any term by the preceding term, we get a common ratio which is common to all of them. That is what we call common ratio. And if the ratio are common, we'll classify the series as geometric progression. Geometric progression. As we have learned in arithmetic progression, first term is represented as a. The common ratio would be represented by r, right? The last term or nth term are represented by L or Tn respectively. We learned how to find R, that is common ratio. The first term, that is very clear, is 1, right? And as you can very clearly see, the last term or the nth term is 16, right? 16 to be over here. Now, we have learned how to find Tn, general formula for Tn in arithmetic progression. In this case, the general formula for arithmetic progression would be Tn equals to A R to the power n minus 1. You have to learn this formula. Now, where would we use this? Let's say in this same progression, they would have asked what the next term would be. 1, 2, 3, 4, 5, 6. What would have been the sixth term or seventh term? How would we have answered? We would have said, since you are asking a sixth term, T6 would be equal to AR. 6 minus 1 would be 5. The value of A is 1. The value for R is 2 to the power 5, that is 32. Simple as that. That is how you use the general formula for Tn in a geometric progression. Similar question I'd say. You are given the first term, which is 216. You are given the common ratio as well, which is 5 by 6. You are asked fourth term, that is T4. You know that formula for Tn is A R to the power n minus 1. Over here that would be 3. Put the values 216 times. The common ratio is 5 by 6, which is cubed. So we'll write it 3 times. Cancel 6 gives 216. They get cancelled. That is 125. Option D is our answer. Now, although we learned the actual process of solving this problem, we, at the very instant we read the question, would have thought that fourth term would be represented as AR cube. That means the final answer should be a multiple of a perfect cube. And the only option which is a multiple of perfect cube is 125. 127, 123 or 129 are not perfect cube and are neither a multiple of a perfect cube. So we would not have actually had to solve this entire thing. All right, anyway, we are just learning the methods. Similar question, I'd say, very simple. We are given the first term, which is 6. The common difference, we know we take any term and divide it by preceding term, which comes out to be 3. We are given Tn, which is 39366. We write the formula, which is Tn equals to AR to the power n minus 1. The value of Tn is 39366. The value for A is 6. Okay, I by mistake have written D. It should be R, right? We are not finding common difference, we are finding common ratio, which is 3 n to the power 3 to the power n minus 1. If we divide the entire thing by 6, we get 6 5 6 1, something like that. Now, well, we can prime factorize it using 3, but I'll prefer 9. I'll write 9 times divided by 9. We get 7 2 9. And we know that 9 is 3 squared, whereas this is 9 cubed. Or let me write this like 7 to 9 is 9 cubed. That would be 9 to the power 4. That would make it 3 to the power 8. So we can write this as 3 to the power 8 equals to 3 to the power n minus 1. If we compare the exponents, we get n equals to 9, which is option D. Simple as that. Alright, now we are going to learn about geometric series. We are going to learn about geometric series where we find the sum of entire geometric progression. Now there can be two cases. Either they are finite or infinite. Let's say if you are given say 1, 2, 4, 8, 16, this much, and you are asked the sum, you'll say this is a finite term. This is a series of finite terms. We'll use this formula, which is A multiplied by R to the power n minus 1 by R minus 1. You can as well use this formula. Last term multiplied by the common ratio R minus A by R minus 1. You'll have to learn these formula. Let me encircle it. Now, if it is infinite, if the number of terms are infinite, there can be two cases. Either R can be greater than 1 or less than 1. I'll give you an example. If R is, let's say, 4 by 3 or 5 by 3, we'll say the R is greater than 1. And in such cases, the sum of all terms would be infinite. You cannot calculate it. But if the R is less than 1, let's say 1 by 2 or 1 by 3, you say the sum of all terms is calculated by the formula A by 1 minus R. Simple as that. Let's solve a few problems that will be more comfortable for you guys to understand. Here comes the question. We are given a finite series and we just learned the formula for sum of all the terms in a finite series is A R to the power n minus 1 by R minus 1, or it is L times R minus A by R minus 1. These are the two formula, whichever you wish to use. I'll say anyway we have to find the value of A, which is 3. The common ratio would be 9 and the preceding term is 3. That would be 3. Okay. We are supposed to find the sum over here 2 to 4 to 6 and to 8. There are 8 terms. So the value for n would be 8. We have gotten all the values, Whichever formula suits you the best, you'll use the formula. I feel since we have the last term, we should go with this formula. S8 would be equal to L, L which is 6561 multiplied by R which is 3 minus A again which is 3 by 3 minus 1. That would be 3 times 6560 by 2. I took 3 as common, right? Divided by 2, you get 5 over here. That would end with, I can very clearly see, that would end with a 0. 6 5s are 30. And the only option having 0 in it is option B. So this is how you find the sum of all the terms in a geometric series. Now, we could have solved it differently, although this is a proper method to solve such questions. Generally, the examiner actually loops some trick in it. If you observe, all the terms over in here are divisible by 3. So, the options, the answer, correct option, should also be divisible by 3. Let's check. 16 and 19 and 27. That is 19. No, that is not divisible by 3. Let's check with this one. This is anyway divisible by 3. We know that. 9 and 14 not divisible by 3. 9 and 9, 8 is still the remainder. So the only option divisible by 3 is option B. We need not have to solve this entire thing manually. Most of the times there would be some trick in questions. So please ponder over these things. Similar question, but over here it is a infinite series. And for infinite series, we learned the formula for Sn to be a by 1 minus r. So we'll write the formula Sn equals to a by 1 minus r. It is very clear over in here that the first term a is 3 and the common ratio. How do we calculate common ratio? Take any term and divide it by preceding. You get alpha, right? Now over here the sum as well is given, which is 45 by 8. We'll put down the values. 45 by 8 equals to a which is 3 by 1 minus r which is alpha. Let's try to solve this. We'll cancel 45 by 3. It will be 15. 15 minus 15r equals to 8. That would be 7 by 15. R would be equal to 7 by 15, which is option A. Simple. Need to learn the formula, guys. Okay, now we are moving into harmonic series. What harmonic series is? In very simple terms, it is reciprocal of AP, which is arithmetic progression. If you observe 6, 9, 12, 15 are all in arithmetic progression. The difference between them is 3. It is just that you have reciprocal them. Instead of writing 6, you wrote 1 by 6. Instead of writing 9, you wrote 1 by 9. So all the formula which used to be applied to AP would be applied to harmonic series as well. Let's see. Very basic question, I'd say. It says second term of an HP is 1 by 5 and second term is 1 by 5 and the fifth term is 1 by 11. But we are going to solve it using arithmetic progression, so we'll reverse the terms. we'll say let second term be 5 and the fifth term be 11. We are supposed to find eighth term. How do we do so? We say if we subtract t5 and t2, we get 6, which is, if you subtract t5 and t2, you get 3d. 3d equals to 6, d equals to 2, right? And you're supposed to find eighth term. t8 equals to t5 plus 3d, right? t5 equals to 11 and 3d would equal to 6, that is 17. Now, obviously 17 is not going to be our answer because this is an AP. Whatever we solved was in the format of AP, 5 something as first term, we don't know, all the way up to 11, all the way up to 17. This was an AP, but we are supposed to find the term of HP. So instead of writing 17, we'll write 1 by 17. Simple as that. Now we are going to learn about mean. Mean can be referred to as average. Okay, so we have learned three different progression: arithmetic progression, geometric, and harmonic progression. We are going to find the mean of all the three. The formula for arithmetic mean is a plus b by 2. Geometric mean would be root under ab, and for harmonic mean it would be 2ab by a plus b. Have to learn this basic thing actually. Now let me write a question actually. I'll say find all three for say 4 and 9. Very simple that would be, and these questions are directly asked in exams. Arithmetic mean, the formula for arithmetic mean is you add those two divided by 2. So the sum of 4 and 9 would be 13. 13 by 2, that is 6.5. Simple. For geometric mean, it is root under the product of these two. The product of these two would be 36. That is root under 36, which equals to 6. Simple. And for harmonic mean, we say 2 times the product, that is 36, by the sum, which is 13. Well, we cannot solve it. We'll just say 72 by 13 is our harmonic mean. Basic question, again, based on formula. Now, there is as well a relation between, let me bolden this, there is a formula between, a relation between arithmetic mean, harmonic mean, and geometric mean. The product of arithmetic mean and harmonic mean is equals to geometric mean, and we are going to use this directly in some question. Okay, let's use the same over in here. The value for harmonic mean, has been given, which is 10. The formula for value for geometric mean is given, which is 12. You're supposed to find the value for arithmetic mean. The formula is very clear: hm multiplied by am equals to gm squared. hm is 10, am, we don't know the value for am, but the value for gm is 12. 12 squared. That would be 144 by 10, that is 14.4. Option D. Simple as that. You as well have to keep this in mind, that the value of arithmetic mean compared to the 3, the value of arithmetic mean is the lowest and the value highest, and the value for harmonic mean is the lowest. So if ever you are given, let's say, a question, 5 and 6 are two terms, find am, gm, and hm, and compare the three, don't actually start finding AM, GM and HM. Just take the option which says AM to be the highest and HM to be the lowest. Simple as that. Remember this. If you forget this sequence, what you'll say is, at least you know AM, GM and HM right now. You will just count it alphabetically. A, then comes G, and then comes H. So that will be a sequence, very simple as that. Last question I'd say. It says X is the harmonic mean between Y and Z. We know the formula for harmonic mean is 2AB by A plus B. Over here it says X is our harmonic mean. I'll write X over here. And the remaining two numbers are Y and Z. Let's write 2YZ and Y plus Z. We are supposed to find a relation between them. Very simple. I'll say move this to the LHS. XY plus XZ equals to 2YZ. Or shall I say, if I would have moved this to LHS, we would have gotten minus 2YZ equals to 0, which is option B. Very simple. This was all about harmonic progression, geometric progression, and all the three means. I hope you liked the video. Now, if you like the video, please do subscribe, like, and comment any suggestion if you have. And do visit the PYQ series which we have started a day before. Thank you. Have a nice day.